Hello everyone, welcome in. We have just opened up the room, so we are just waiting for everyone to come in. So we're going to start right on the hour as well. Thank you so much for coming to today's session. If you can hear me, if you can put in the chat where you're from, so that'll be great so that we know that there are people in this session. Always good to see where everyone is coming to join us from for today's webinar. So nice to meet you. We have teachers that are joining us from Egypt. We have teachers that's joining us from South Africa as well. Welcome, everyone. We have teachers that comes all the way from Kenya, Malaysia. Welcome. Good evening to you. Welcome to everyone. All right, I think we are ready to start. So I'm just going to pass the time straight to Mark to begin the session. Mark, over to you.
Thank you, Ken. Hello, everybody. My name is Mark Heslop. I'm from Manchester in the UK. I'm your subject partner for International Maths. It's great to see where everyone's coming from around the world. Basically, if you've got any questions or anything you want to discuss with each other, please do put it in the actual chat itself. We will try and keep an eye on that, but it tends to go by fairly quickly. If you've got anything specific that you would like us to answer, please put it in the Q&A sessions. And I have just seen we've already got one comment. So I would like to know if both math papers are still calculator based. Yes, our papers are calculator based. Non-calculator assessment is important. So we do have occasional questions in there. So higher tier students, show that the rationalization of this surd can be put into this form. Foundation tier students, show that the summation of these fractions is this, where we get students to demonstrate their non-calculator knowledge. I am going to say that students can use graphical calculators at international GCSE level. There is no real advantage to using them at this level. They're a great tool in class for exploring maths. They can use them in the exam. There's no real extra functionality that gives them an advantage. But I will say that if they're going to use them in their post-studies, then actually it's an advantage to get them used to using graphical calculators in their international GCSE, so it's less of a step up. So I've just seen Sanya's coming and provide a few sample papers for non-calculator exam. So we don't have a non-calculator exam, Sanya, but there are questions available. If you want to look for non-calculator questions, I would advise looking at things like certs, and I would advise looking at things like foundations, foundation too. Okay, so agenda for the day. Do a couple of reminders, talk to you about some resources. And Zainab, I've said the calculator will be allowed in both papers. And we have no plans to change that. Progression of topics, research rules, progression of topics, and revision considerations, and then finally just any questions from you. Just a few reminders from me. Caching codes. So we've got, for those of you making the modular entries this summer, I've seen actually quite a few centres enter for their exams officers and have entered for the paper. The relevant paper, so paper 1, paper 2 for higher or foundation, but they haven't entered a caching code. And we don't want there to be any delay on results day of your students effectively getting the results. So if you've not entered for modular qualification course, for instance, if you don't make entries with our international A-level, just have a chat with your exams officer to check that you've got the caching code, which is what pulls the results together to generate a grade. Tier changes, you can, if you've got any queries over the tier of your students, you can actually make tier changes on the system until the 22nd of April without incurring any extra cost. So, on to the resources. I have some new things for you. So, we have 2 sets of sample assessment materials available for you on the website. What I've done is I've actually classified 478 questions for your students to use as revision worksheets. It was a fun job. So I've split these by foundation tier and higher tier by topic. So those should be going on the website, I hope today, and there will be a printer-friendly version of it going on the website later this week. Because I know maths teachers and heads of departments, we get some grief sometimes for how much printing that we have to do. So yes, there will be a printer-friendly version where effectively what I've done is I've removed all the white space, which reduces the printing. But there are literally hundreds and hundreds of pages of these, and mark schemes are there for your students that they can just zoom in on a topic and say, look, I want to practice a bit more of that. It's a split between Unit 1, Unit 2, Foundation and Higher. So we have, for instance, here, this is the revision sheet D. There's the mark scheme. There's a printer-friendly version of it. So this one's a higher tier one. The other ones are labeled Foundation and Higher. And just a reminder that your higher tier students do need to engage with the Foundation and Higher topics. They're the basic questions that could cross over between Foundation and Higher. So just make sure your higher tier students are aware of those ones as well. Okay. We'll also be putting out later this week an exemplified revision checklist that's going to be aligned to those revision sheets. So this is where we've taken the specification and actually put some wording to it for it to make sense to students. There's some of these statements in the scheme of work in the specification. You think, okay, how would we assess that? So we've given little examples. We're not saying that these are representative of the range of questions. They're just to give some context. So, what does understand place value mean? Well, a question could be, write in figures the number 2018. Okay. Just a reminder also, if your students, when they're using the revision resources, want to go look something up in the textbooks, we have a mapping document that shows you exactly which topic is listed in effectively in book 1 or book 2. The textbook team are working currently on a modular version of the textbooks, but I can't comment on a release date at this moment in time. What I will say is, out of the 50 chapters in total, 37 chapters are entirely contained within Unit 1 and Unit 2. And I've just seen Amina's, absolutely, I'm just going to go back one, the revision checklist and the revision worksheets absolutely work for the linear. So if you're choosing, say, the algebra topics for your linear students, they need to do effectively the Unit 1, or they can work with the Unit 1 and the Unit 2 algebra section to cover their content. So absolutely, I did have it in the back of my mind, how will students use these for effectively if they're still doing the linear examinations. Okay. Reset rules, just a reminder. So the intention of modular is not for students to be just put through resets and resets and resets. So just a reminder that learners can reset any unit irrespective of whether the qualification is to be cashed in. But if a learner resets a unit more than once, only the better of the two most recent attempts of that unit will be available for aggregation to a qualification grade. We don't want students to be taking a Unit 1 this summer and then prospectively resitting it in the autumn and then again next summer. That's not in the interest of the students. This is about helping them manage their revision, helping them manage their exam stress. So if they were to do 3, so this summer, October, and next summer, only the best of the most recent 2 would actually count for their cash-in. So an exam that they did this summer would not count. So please only put your students through for a resit if it's needed. Because if they do really well this summer and in October and then next summer don't do as well, this summer's great result won't count. Okay, just going to check, see if there's any questions from the chat, but I think we're good to go. Okay, so just a reminder now of that progression of content. So when we split the content up between Units 1 and Unit 2, topics were carefully chosen to allow a progression of topics and also gather together topics, say, for Unit 1 or for Unit 2 to reflect how questions are actually pulled, or how topics are actually pulled together to create questions. So actually, if you're looking for histograms questions, you'll see often they involve some element of probability. So we'll say, work out the probability that some section of the population or someone chosen at random is in section of the population. So that's why you'll see topics like histograms actually pulled into the same unit as the probability. Teachers did feel it important that we have number, algebra, geometry, and handling data in both units, especially for foundations here. There's a slightly higher emphasis, I guess you could say, on number and algebra in Unit 1, as it underpins everything from with a lot of other questions. And there is a common question: is do students need to revise all of Unit 1 for Unit 2? And the answer is not really. Effectively, we're taking the same approach as our maths. So students engage with, say, quadratics in Unit 1. They don't need to revise it in Unit 2 because they're automatically re-revising it as they're engaging with material in Unit 2. For instance, your higher tier students engage with nonlinear simultaneous equations where they need quadratics. So we've taken the approach to try and choose the arrangement of the topics. So they're automatically re-revising the Unit 1 topics as they're studying and revising for the Unit 2 topics. What I will say is we won't, sorry, I've gone too far there. You won't see a topic in Unit 1 as it would be in a Unit 2 question. So the Unit 1 knowledge will form, say, a subpart of a Unit 2 question where it's extended. But you wouldn't see a topic that's effectively a pure Unit 1 question as it is in Unit 2. Rob from QA, is it fair to say that Module 1 is predominantly IG Linear Book 1 and Module 2 is predominantly Book 2? No, you need to mix between the two chapters, Rob. And if you go, when you get a copy of these slides, there'll be links to, say, the mapping document that shows you exactly where the content of Unit 1 and Unit 2 is. But like I say, 37 out of the 50 chapters are entirely contained within each of the units. So in terms of that progression, so in Unit 1, we have basic number skills, we have fractions and decimals and very basic percentages. So expressing something as a percentage. We don't have percentage increase, percentage decrease, compound interest. It was necessary to have that basic percentage, so expressing as a percentage in Unit 1 because we have percentages in there. How many I've just seen your comment about where can we find the revision packs? They'll be uploaded later today, and when they're uploaded, I'll get Ken to send the link down for you. So we have the basic number skills in Unit 1. So, like we've said, limits of accuracies in Unit 1 for both tiers, with harder questions for your higher tier, and surds and indices is there for your higher tier students. Progressing through into Unit 2, we have the ratio and proportion skills, percentage skills. So is Unit 2 foundations? So I've just seen a question here. Is Unit 2 foundations considered an essential for Unit 1 higher? No, it is Unit 1 foundations, Dina, that is essential for Unit 1 higher. So percentage skills, percentage increase, decrease, reverse percentages. Standard index form is in Unit 2, which builds on the work of the basic number skills. So indices manipulation is in Unit 1. Applying that into standard form is the way we revise it in Unit 2. And then repeated percentage change. Give you another example of the split. If you go into the detail of the specification, in the basic number skills, we have expressing something as a product of its prime factor as part of the indices work in Unit 1. Highest common factor and lowest common multiples are the skills that then we revise those as we move into Unit 2. That's all going to be in the revision checklist for you, that exemplified version of the specification. So, progression of algebra topics. I'm just going to rearrange my windows here a little bit so I can see your comments a little bit better. Okay, so we have in here basic algebra skills, which covers things like solving equations, rearranging equations. I'm going to make a specific comment on that in a second. Set notation is in there in Unit 1 because we have Venn diagrams in Unit 1, because we have probability in Unit 1. Plotting graphs is in Unit 1. And I am going to pass a comment in the revision tips on equations of straight lines. Solving basic quadratics. So for your foundation tier students, effectively only x squared. For your higher tier students, multiples of x squared. Quadratics was a topic it was felt to be important to put into Unit 1 because it underpins so many of the problem-solving questions that we have elsewhere in the syllabus. So you'll see, for instance, often shape and space questions can sometimes result in a quadratic that needs to be solved. They need to form and solve a quadratic. So it was important to put quadratics in there in the Unit 1. Completing the square is in Unit 1, and then the quadratic formula is in Unit 2. Okay, and this is where I often get the most questions. I'm going to come down to it here, change of subject. So inequalities. So those solving equation skills that we have in Unit 1 are then re-revised in Unit 2, where we ask them to solve an inequality. Simultaneous equations is in Unit 2. This is where we introduce sequences. Change of subject is formally in Unit 2. Rearranging equations is in Unit 1, and this is where we apply rearranging equation skills to be changing the subject of a formula. So for your foundation tier students, where the subject only appears once, and where the higher tier students is where it appears more than once. I've just seen a comment from Garda. I'll come to the shape and space in a section in a second. But bearings, for instance, is a Unit 2 topic. I have had a couple of comments, and we are adjusting the scheme of work. So many students have encountered bearings in Key Stage 3. And there are a couple of parts in the Unit 1 scheme of work where it says you could, work with bearings at this point here to give context. It's not a requirement, but it sometimes gives a nice context. But we'll make that clear in the scheme of work. Algebraic proof is formally in Unit 2. Direct and inverse proportion algebraically is in Unit 2. And I will clarify that we could ask students in terms of plotting graphs to interpret a graph in terms of a conversion, so conversion between currencies, that is Unit 1. Algebraic proportion is in Unit 2. Summation of arithmetic series in Unit 2. Function notation and transformations is in Unit 2, and that transformations of graphs dovetails in with something else I'm going to say in a second. And then differentiation is in Unit 2. Okay, AO2, shape and space. So properties and areas of shapes in Unit 1. Trigonometry is in Unit 1 for our foundation and higher tier students. Compound measures, speed, density, and pressure. Sine and cosine rule for our higher tier students. Sine area of a triangle for our higher tier students. And 3D Pythagoras theorem for our higher tier students. Progressing that through into Unit 2, and I should say things like properties and areas of shape, they're often the ones that for your higher tier students can result in, at the end of the paper, as a nice problem-solving question that results in a quadratic, hence why we need quadratics in Unit 1. Unit 2 is where we actually start to bring in angles in polygons and circles, but areas of shape includes all 2D areas. So for instance, areas of circles. I've just seen a Mira's comment. Inverse function, we use completing the square to get the inverse function. So let me just go back and just check a couple of these questions. Spec B papers, I'm not passing comment about Spec B papers here. This only refers to the specification. So this is entirely about the specification A. And in inverse function, we use completing the square to get the inverse function. You're absolutely right. That comes in 2H, and so I'll go back here. So function notation and transformations, you're absolutely right, Amira, that inverse functions can involve completing the square, and that's the application of completing the square in Unit 2 that helps students to revise it. Okay, so Unit 2 here, this is where we bring in angles and polygons in circles, symmetry, it's where the constructions is, and also the bearings. Volume, so we've got 2D area leading on into 3D shapes and volumes. So Luma, I've just seen your comment. As we said earlier, bearings is in Unit 2. Similarity is in Unit 2. Data, speed graph, time graph, so the graphs is in Unit 1. So I'm just going to go back here, plotting graphs, Unit 1. Similarity, transformations, so describing transformations, so this is shape and space transformations, but we actually put that in Unit 2 to go with the algebraic transformations for your higher tier students and transformations of functions. Circle theorems is in Unit 2, similar area and volume, and then vectors is the final topic on shape and space for your higher tier students. In terms of handling data, so effectively, all the probability is in Unit 1, and this is why we have histograms, and if you look into the detail of this, you'll see, for instance, two-way tables is also in Unit 1, because we often ask probability questions of those. The measures are in Unit 2, so statistical measures and cumulative frequency diagrams are actually involved in Unit 2. And the examiner, I'm going to show you a list in a second of, actually the examiners have said, these are the topics from Unit 1 that the students don't need to revise for Unit 2. the reason is, there is a logical progression of topics from Unit 1 into Unit 2. For instance, like someone said a second ago, completing the square in Unit 1, inverse functions in Unit 2. We can use the completing the square skill. There was no logical topics that we could actually put together with some of the Unit 1 topics to create a Unit 2 question. So the examiners logically said, we're fine saying we won't assess these topics in Unit 2. There's nothing logical that we can do. So students don't need to revise these to make their revision more manageable. Probability is one of those questions. I'll show you a full list in a second. Okay, Unit 1 content. There we go, from AO1. Higher tier topics are underlined here. So converting recurring decimals into fractions is definitely only a Unit 1 topic. They do not need to re-revise this for Unit 2. I am going to come to that in the revision question section in a second. Upper and lower bounds, again, a Unit 1 only topic. Set language and Venn diagrams, because Venn diagrams have to go with probability. Probability is Unit 1 only. These are only Unit 1 topics. From shape and space, understanding the relationship between average speed, distance, and time, which actually answers Garda's question. So it's only Unit 1 and doesn't need to come up in Unit 2. From handling data, construct and interpret histograms for your higher tier, and for all students, probability. So it's worthwhile giving that list to your students and saying, we've constructed Unit 2 to rely on the content of Unit 1, so you're automatically revising it to make things as sensible as possible for students in their revision. It's just like if you're teaching our international A-level, Pure 1, indefinite integrals. Pure 2, definite integrals. You're already re-revising that Pure 1 content as you're doing definite integrals. Okay, there are certain topics, these ones here, that students do not need to revise and will not necessarily be revising as they're revising for Unit 2. It's one of those things of spotting what's missing is actually the hardest part in here, rather than spotting actually what's there. I hope that's going to be useful for your students. Okay, so revision considerations. So this is, for me, it was a really interesting one. So effectively what I've done, I've looked back at the feedback from last year and picked out topics that we just maybe need to highlight to students and will have an impact to highlight to students in the remaining weeks of the course. I think some of this stuff is where students perform poorly and we just need to show it to them as a lesson start. Just get them to engage in a few questions on this will be enough. These are not big things that you need to reteach. There is one technical topic in here that I'm going to say, if you've got teaching time left, it is worthwhile spending time on with your students. But the majority of this thing in here are topics that we just need to briefly refresh the students' memory with, re-engage them with, remind them with, and I think it will probably pay dividends. So I'm trying to be as efficient as possible on this and give you things that you can have a real impact on in your classroom. So, okay. So here's a question from Foundation Tier, and I'm actually going to show you some of the statistics. I'm going to compare a couple of the questions here. So write these decimals in order of size. I've got a few from Foundation here and a few from higher. Start with the smallest decimal, and then this one here, write down the value of 3 in the number 1324. I'm actually going to compare these to a question 8 from the Foundation Tier. Barsha buys some nails and some bolts. Each box of nails costs this. How much buys 5 boxes of nails, 4 packs of bolt, pays with a £50 note. How much change should he get? Okay, I'm going to show you the comparative statistics of those two because you may be surprised. So in part B, some students confuse themselves when ordering decimals between the numbers 0.13 and 0.7. So this is where they classically say 0.13 and 0.7. In part D, place value caused problems, some students hundreds being the most popular wrong answer. So here's the statistics. So here's part B, 72% of students got that correct overall. 57% of students got this, which is, may shock some of you. And yet when we compare it to that question 8, students got on average 92% of the marks. I'm going to let that sink in for a second. Compare these. And I don't think we need to reteach part B and part B. I think this is potentially just showing some of these kind of questions, and there's plenty of these kind of questions for you in the revision sheets that you can use. And it's just a case of refreshing that knowledge. A lot of this is just Key Stage 3 knowledge that we assume students know. And therefore, we think they're okay in it. It turns out that they're less good at it than we think, and they just need to be reminded. I'm just going to refer to a couple of comments in the chat. So I've seen Shireen's comments are there'll be no upper and lower bound with problems on 3D volume and surface area. Correct. That's a Unit 1 topic. There's plenty of other topics from Unit 1 that the examiners can create upper and lower bounds questions on. They don't need to create them on surface area and volume. And Dina's question, Unit 1, students going to be asked to solve quadratic equations from graphs, like for instance, x squared plus 5x plus 6 equals x plus 1. They could be conceivably be asked to solve that from just solve that equation is Dina. But they wouldn't be asked to solve that graphically. That would be in Unit 2. They would be asked in Unit 1 to find the roots of a quadratic, but they wouldn't, for instance, be asked to find, they're given a plot a quadratic, and I did ask the examiners about this last week when I was putting the revision sheets together. Here's a quadratic, plot it, and there's a slightly different quadratic, and they've got to tease out what linear equation it's been solved with as the next stage to your equation you put down there. That would effectively be Unit 2, sorry. And then are the revision worksheets available in Teaching Hub? They're going to be available on the website. They're not going to be padlocked. I want students to be able to access these. Okay. So my point on this one is I think we just need to remind students of these. I think just a quick reminder here is all that's needed rather than reteaching. And that's going to be the theme for the most of the topics that I'm talking to you about here today. Okay. Give you another example. How well do your students know their calculators? I think the answer is possibly not as well as you think. Find the cube root of 373,248, and I'm going to compare that to write one set of brackets in each calculation to make the answer correct. And I'm going to show you the statistics of these two. So here is part B. Only 57% of students knew how to find the cube root of something on their calculator. And I'm going to ask you to compare that to the 97% of students who knew how to square a number on their calculator. Likewise, DI, comparing this, adding a set of brackets in here to get the order of operation can be quite fiddly for students. And yet, 87% of students got that mark. And let's compare it back to that cube root. 57% of students knew how to use the cube root symbol on their calculator. So again, re-exposing students to this. This is not something that's going to take long. Once students have had that knowledge refreshed in their mind, they will be fine with it. But you can use some of the very basic questions on the, especially the number section of the revision worksheets. You can show them up as a 5-minute lesson starter. Quick one for this lesson, ladies and gentlemen. Let's refresh their knowledge. So other as I said soon, and the more practice papers to be published following the modular system. So we've got 2 sets of practice papers on the website. They're padlocked for teachers to distribute now for mocks and for revision as they see fit. You have these revision worksheets for Unit 1 and Unit 2. There's 27 of them, and I'm going to say, including the mark schemes. I think someone looked at what we put together the other day. I think there's about an average of about 30 to 40 pages for each one. There's plenty of revision materials to go out there. They are working on a 3rd set of mock papers for you, but these will be released over the summer for your schools to use in their, if they're doing an internal end of year 10 mock examination. And I know the exams will come out, but the mark schemes won't come out until sometime later. But we want something for schools to use this summer for internal mock standardization. Teachers ask me, what should I use as grade boundaries? The modular papers are written to the same standard as the linear papers by the same team, using the same progression of difficulty through them. So until the actual results come out this summer, we can't really pass comment on the grade boundaries, but as the papers are written to exactly the same standard, with exactly the same range and gradient of difficulty, a lot of teachers tell me to get an idea, they're using the grade boundaries from, for example, last summer. Okay, let's go on to higher tier. So with foundation, I think a lot of this is just a refresh of the basic knowledge. Will make big differences in the exam. There is some of the higher tier comments that are relevant to foundation tier. I'm going to compare these two questions for you. Find the interquartile range of the number of goals and solve these simultaneous equations. I think you can probably guess what's going to happen next. So these green statistics, by the way, are in the top 10 answered questions on a paper. The red are in the bottom 10 answered questions on a paper. The simultaneous equations, students scored on average 87% of the mark. Finding the interquartile range of a number of goals, the average mark was, the average student scored 69%. I'm going to say on interquartile range, I'm aware there is a variety of methods there for finding the quartiles. The examiners actually don't mind. They're aware of these key methods. They're absolutely aware of the different methods out there. And they design the question so whichever method that the student uses, it produces the same answer. What we're after at this stage is an appreciation of quartiles. I think if any of you have used the statistical package R, and some of you feel very strongly about this is the correct method for quartiles. If you've used the statistical package R, I think there's 11 different methods of quartiles on there. But the basic methods, the examiner design the question so that it produces the same answer regardless of what method they've actually used. And as I've seen, if you're referring to the sample papers, they're available on the Pearson website. So in terms of the practice paper, Professor Noah, they will be available on the website later on today. Okay, so yes, sorry, I should say my point in here is that higher tier students, and to a good degree foundation tier students, make sure they're engaging with the revision material on the handling data, the probability, and the statistics. So certainly the statistics section is one that higher tier students, we assume they know this stuff. Well, there are actually some quite basic things that they don't know. It's not one that you're going to need to reteach them. Just them engaging with this material and realizing that they don't know how to do quartiles. An average higher tier student will be able to sort that out for themselves, or will they have the knowledge to actually ask the question from you. But if there's a kind of a general area for higher tier students, handling data is one to make sure that they're engaging with the revision worksheets. Okay. Circle theorems and to a degree geometry in general. Okay. So students on average scored 48% of the marks. And it's this point here. Give a reason for each stage of your working. Common question in geometry is to ask them to provide a reason. Some students lose marks because they're not using the correct statements. They're abridging too much. So they might say angles in a triangle are 180 degrees. That will not get them the mark in the exam. So I always say to my students, it's okay to lose the marks that you can't do. It's not okay to lose the marks that you can do, but you just haven't hit the right level in an examination. So do show them mark schemes. So opposite angles in a cyclic quadrilateral sum to 180 degrees. Angle at the center is twice double the angle at the circumference. Angles around a point add up to 360 degrees. It's an isosceles triangle. They can quickly see what they need to be working on in terms of the mark schemes themselves. But I wouldn't want your students to be losing these marks when the examiner actually know what they're talking about. They haven't used certain keywords. The examiners are not allowed to award them the marks. Is tan rad acceptable? I'm not entirely sure what you mean there, Rob. So I don't think it would be, just because I'm not sure what that means. I don't think the examiners would know what that means either. There is another key point on this one. The students often get lost in their explanations, and there's a good comment here in the mark schemes that you need to show your students. Angles to be identified either by notation or correctly positioned on the diagram. It is okay for students to work on the diagram with calculations and put step 1, step 2, step 3 with a calculation for what's relevant. And then here, step 1, here's the reason. Step 2, here's the reason. Step 3, here's the reason. Cognitive load, that is an order of magnitude lower in terms of cognitive load level. And the examiners say when they see students working on the diagram, clearly labeling the steps, the order of their steps, and putting those steps underneath, students are getting more marks. So we would encourage your students to do this. If they can't see the order of what they've worked in on the diagram, they can't really award them those marks for the reason. So it must be clear. They could put a 1, circle, 2, circle, 3, circle calculation for those angles. It just reduces their cognitive load. Can we call angle at a circumference inscribed angle? I think they can get away with that one, George, but do send me an email afterwards into the teaching maths inbox. So teachingmaths@pearson.com, and we'll ask the examiners directly on that one. Okay, transformations. Often a one that students do struggle with, but and describing transformations, but in this case here, not for the reason you think. So A, describe fully the transformation that maps shape A onto shape B, and on the grid, rotate shape A 180 degrees, label your shape C, about a non-zero origin. Now, I'm going to say students do struggle to describe transformations. Not usually, I would say. You wouldn't say translation. They certainly struggle to describe an enlargement, and they do struggle to describe a rotation. So what they will often do on a rotation is call it, so we'll ask them to give the single reason, and they will describe a translation and then a translation and then a rotation, and that won't get them the mark. And I don't think it's that they're misreading the question. I don't think they're just going, okay, I just need to put some transformations down. I think we should indicate that to mean that they don't know how to describe a rotation. So I think that's the root cause. The solution to it is plenty of practice. So there's plenty of these on the revision materials. But when I show you the statistics for this one, because there is something important comes up. 2A, students scored on average 47% of the marks on describing the single transformation that maps shape A into shape B. And 2B, actually rotating a shape around a non-zero center of rotation, they scored on average 74% of the mark. Now, most of you will find that very, very surprising. Could anyone tell me why they lost more than half the students, didn't get the right answer for describing a transformation? Give me a chance to have a quick sip of tea. Please do throw something into the chat. That's a very good point, Bethany. So I'm going to elaborate on that one. Often if we have shape B here and shape A there, and we ask them to describe how we get from shape A to shape B, they will automatically read from left to right. I don't think it's the reason here. They do tend to go from the leftmost shape to the rightmost shape. It's definitely worthwhile highlighting that to your students, that they might be having to go from the rightmost shape to the leftmost shape. Loomis hit it on the head. They must use vectors. Okay. So they must use a vector. The examiner said the word translation was reasonably well known and related to this question, though it was also common to see general description such as down 5 and 3 right. Some simply wrote about the shape moving. Perhaps more guidance needs to be given to students on the word describe in this question. And also the instruction that it is a single transformation, but they must give answers for a transformation, a translation. They need to say it's a translation, and they need to give it in vector format, please, to be awarded the mark. And that comes as a surprise to a lot of people. Again, a relatively easy one to fix. Okay, set theory. So we're talking unit 1 here. I'll show you some of the statistics. It's quite interesting how students actually fall down on some of this notation. You can see here, B is one of the ones that fall down, and I'm going to come to that. Where students actually struggle is actually interpreting these. So when you're working through the revision material with them, my advice would be to get them to, for instance, write out a worded explanation of what this means. And doing that in an exam can give them just a little bit more soak time, a little bit more absorption of the question information time to allow them to access the question. So for instance, A union or B, getting them to regularly write that down is something that can lead to just clarifying whether they know it or not in their own minds as part of the revision. Part B here. Okay, so we're saying A and B is an empty set. So I think there were some issues in here with the use of the empty set. Students do also struggle with the notation for the number of elements in the set. So again, engaging with these materials as revision, perfect, but just refreshing that knowledge quickly. Harpreet is incorrect. Explain why. Okay, so I have a lot of teachers tell me students do struggle with explanation answers. And I'm going to say, generally speaking, that is not true. I spend a lot of time each year really going through the data of what they can and what they can't do. Students can do explanations. There is a subset, which is ironic because of the questions that were on here, a subset of explanation questions that they need to practice more of. It's explain why something is not the case, explain why somebody is incorrect, is a level of explanation that they just need a bit more practice of. So if you're going to focus on the explanations, go for often the sequences questions are a very good source of these. Is this explain why this is not a number in a sequence? So it's those explanations of why not, or why something's incorrect, that it's worthwhile practicing on. Okay. Algebra again. So we've effectively got recurring decimals, and then we've got quite complex FG of K equals 2. Statistics. For the question 17, students scored on average 6% of the marks. And actually for a fairly, standard run-of-the-mill procedure, in question 18, students scored 56% of the marks. So if there's a question to work on, topic to just practice on, your higher tier students, it's converting recurring decimals to fractions, unit 1 topic only. I think it just needs a little bit of refreshing in the mind. It's quite surprising that they can do some of this very hard stuff, but not this stuff. And then a final topic so a lot of that have been just quick refreshers. And I wanted to highlight something to you here as a topic that is worthwhile spending more time on in your final teaching. Aminas, in terms of revision materials for linear exams, you can use these revision sheets for the linear exams. So recurring decimals is on unit 1 only and not unit 2. Okay, so of these questions here, if I were to ask you to just think for a second as to what students might struggle with, and then, okay, we've got some follow-through marks here. I think you might be surprised by the statistics on this one. So there's the mark scheme. Okay, 2AI, y equals 2, 9% of students, x equals 6, 9% of students, y equals x plus 1, 67% of students. They did actually get the follow-through marks here. And actually, where students were very good at creating an inequality from those. And the surprising thing here is y equals x plus 1 scored more poorly than y equals 2 and x equals 6. But I bet you that's where teachers focus their effort on at this stage and making sure students can do. So do not underestimate basic equations of lines. And if there's one topic to go through with your students, it is basic equations of lines in your teaching. So this is a question from the main papers on the higher tier. Find the gradient of a straight line that is perpendicular. Very low scoring question. And I've got some examiner's comments on here. This seemed like a very straightforward question for the grade at which it was targeted. However, we are now very much of a very strong opinion from the evidence from a great number of students that many do not actually know what a gradient is. We were very surprised that most students seem to think that a gradient is a value with an x or an equation, so 2.5x, 5 over 2x. Commonly seen as the gradient, as this was an equation with a gradient of 2.5. Gradients, please, want to focus on in the remaining time of your teaching, both foundation and higher tier students. So key points. So things I haven't mentioned in here, equipment. So please do make sure your exams officer checks at the start of the exam that students have. I've just seen rehabs in the previous question. Should students shade the unwanted region or the unwanted region? To be honest, it doesn't really matter. I find it's easier for students to shade the unwanted region, but they must mark the wanted region clearly is the point. We have evidence that students go into examinations and that they don't have a ruler, that they don't have a protractor. And we know this because when we ask them to measure an angle, they actually write on their exam paper, I didn't have a protractor, I didn't have a ruler. So get your exams officer to do a quick check. Don't ask them to put their hands up. They're not going to want to admit at this stage. They're nervous enough. They're not going to want to admit that they haven't got a kit. Tell the exams officer to get them all their kit out on the desk. A quick scan of an exam hall. I can do it, and the exams officer can do it in about a minute, and then just make sure they've got the right kit. Formula sheets. A lot of evidence to say that students do not know what's on the formula sheet and forget about it. When was the last time you asked your students to look at the actual formula sheet and revise their information in that? Now, Rima, and I've just seen your comment about graphing inequalities, including foundations here. I think we can ask them to do very basic ones, but it'll be in the specification. Just quick check of that will do for you. That would be Unit 2. Formula sheet. There's nothing wrong with your exams officer staying at the start of the exam. When you filled in the front and when we ask you to open the front cover, have a quick scan of what's on the formula sheet. Foundation tier. Don't underestimate the easy questions from Key Stage 3. Geometric reasons worth practicing. Higher tier, definitely practice handling data with them. Justifying why not. So for instance, sequence questions and making sure they're using vector notations. Advanced geometry, work on the diagram, and also set theory notation. Also worthwhile practicing the recurring decimals with them. We ask students to check their work as teachers, don't we, after they've finished, and we know it's too big a task for them. So what I see as the exam script, sometimes I see questions underperforming in the middle of the paper, but they know the questions at the start are going to be fairly straightforward. They concentrate for the ones at the end. I think they sometimes underestimate those middle questions. And my advice is, if you say to your students, if there's an area of this that you should go back and check if you have time, please do check the middle section of the paper, because you might pick up errors more easily there than concentrating, say, on the harder questions at the end. I do hope that's been useful. I've just seen a couple of other comments. Can students sketch graphs using pencils? Yep. For Unit 1, only the required topics included in the exam, absolutely. So the only Unit 1 content will be tested in Unit 1. I do hope that's been useful. Like I say, we'll share the presentation with you, which will have links in, and the revision materials hopefully will be up to date. The student-friendly versions later this week, and the revision checklist for your students, and they're all absolutely usable by linear students. So I've just seen a comment for Shireen. Is factorization allowed using the calculator by putting the solutions back inside brackets, or students must show method at some only do it in mental? General advice, show working. If the students just put an answer down and it's correct, they're going to get full mark. If they put an answer down, just an answer down, it's incorrect, they're going to get no mark. They should always be showing working. Calculators are a great checking tool, but they shouldn't be using it to bypass working. So Jay's comment, what are the implications of a student sitting both modular and linear exams simultaneously? They can't. It's a forbidden combination. They cannot sit modular exams and linear exams in the same exam series. And we have actually had questions common in between them, just to see the questions, just to check performance, a handful of questions, which means that we can't have students sitting modular and linear in the same series. And I'm just going to check the Q&A. So I'm just going to make this a little bit bigger, so I can just see if there's any more questions on here. So I think we've answered the question about bearings being Unit 1. Can a student who has done foundation maths continue to do AS and A levels and do pure mathematics? My advice would be, I've seen students do foundation very much struggle. It's up to your knowledge of the student, but they would need to be topped up with a lot of the advanced algebra that's in the higher tier. Constructions and bearings are not clearly specified under which unit of the syllabus. I'll check that one, but they're definitely Unit 2. Harder graphs is in Unit 1. We could ask in Unit 2, for instance, a student to find the intersection from graphs. I can't pass comment on the grade boundaries being identical for linear and modular. We expect them to be not too dissimilar. Proof is definitely in Unit 2. Geometry, so Amal is divided in Unit 1 and Unit 2, and see the specification. So algebraic fractions, I've just seen Noreen's comment, it's actually in Unit 1. Bearings is Unit 2 content, as we've said. Quadratic inequalities is in Unit 2. I think we've answered most of these. Especially in terms of tracing paper. Students can ask for tracing paper in the exam, but they can't bring it in. They could start a modular in one series and then go into linear in the next, but they can't do it in the same. Formula sheet is included in the start of the exam paper. They can't be given a separate exam formula sheet. In linear series, we can't actually guess which questions would come up in paper 1 or 2. Correct about that. Any content can be included in either paper. What happens if a student forgot and answered the exam paper in pencil? If actually there's any problem scanning the paper, and they would actually go and they would actually go and extract the physical copy. What type of calculator is allowed in IGCSE? You can use any scientific, or they can use a graphic. Our advice would be to see the GCQ website for the calculator FAQs, which gives you advice on putting it into effectively exam mode for the students. And I'm just going to check the chat because that's going over quite quickly. Structure of the linear exam. Sorry, Amina, you can ask those questions, but we're concentrating here on modular. There's no difference between the two papers. Can you categorically say modular and linear paper 1 be different this year as the same duration? They are categorically, as I say, different papers. Are they allowed to use a blue ballpoint pen? It actually says on the front of the exam paper they should use black. So the revision sheets, as we've said, will be on the website later. Does all transformations include transformations of shape in Unit 2? Yes, indeed. Can they use a pen to draw graphs? Yes, I'd advise they use pencil, as it says on the front of the paper. There is only one paper each for each modular approach. Yes, correct. So it's a foundation or higher Unit 1 and then foundation or higher Unit 2. All the foundation exams and higher tier recent exams are locked. Yep, we keep them locked for a year. Can you explain what the justify why not point? So we sometimes see on sequence questions, question like, Fred says 34 is a term in the sequence. Explain why he's incorrect. Recap there. I think we've already covered the formula sheets included in the front of the paper and can't be given as a separate. Mohammed, there is guidance on Maths A and Maths B in terms of our overall maths guide. The majority of our students across the world enter for Mathematics A. Recurring decimal, so Naveen, is a Unit 1 topic and only a Unit 1 topic. The recent papers are locked on the website because they are for schools to use as internal mocks and distribute theirs to their students as they see fit. Okay, Ken, we've gone slightly over time given the volume of questions there at the end. So Professor Noah, I've just seen your comment about accessing last year exams. They're locked. You need an Edexcel online account, which you get by your exams officer there. So I think I'm going to turn off my camera. We'll just give it one more minute.
Thanks, Mark. So just for everyone's information, just in case you didn't catch that earlier, for the resources, why it is locked. So because it is only accessible for teachers and not students. So in case you are wondering how you can get access to EOL or our Edexcel online account, so you can either request it from your school administrator or your exam officers. So you will be able to access those resources on our website. I'm also going to put in the chat box the link to our event page where we will be uploading the recording of this session as well as the presentation slide that Mark has just shared. So you will be able to watch it again as well as refer to the presentation slides if you need to. All right, so with that, thank you so much for joining us once again. We really appreciate your participation and we hope that you have gained some useful knowledge as well as useful information to prepare your students for the upcoming exam series. So thank you once again. All the best for your upcoming IG Maths exam. Take care and bye-bye, everyone.